So, trig extended. How do we know, now that we know like SOHCAHTOA, we know the reciprocal functions. Now we're going to talk about putting kind of 4-1 and 4-2 together. And 4-1, remember we talked about like rotations of angles. Yeah. Okay? So we're going to put that together, and what we're going to do is form something called a reference triangle. And we're going to use the fact that SOHCAHTOA is in a right triangle to find sine and cosine of different angles, not just acute angles. All right, so first of all, this came up a couple days ago. If we're rotating from here, remember the standard position? Standard position means the angle starts straight out from the x-axis. Does anyone remember from geometry, what if the angle is negative?
What?
So if an angle is positive and you're doing a rotation, you're going to go counterclockwise. You're going to go this way. If an angle is negative in a rotation, instead you're going to go clockwise or back that way. What happens then is, because we're talking about 360 and you can rotate either way, there is always going to be a lot of ways to get to the same final destination. So what we call that is, we call those coterminal angles. Okay? So just understand, positives are measured counterclockwise, negatives are measured clockwise. A reference angle is still going to be the acute angle made with the x-axis only. So that's our vocab for today. Coterminal angles are angles with the same initial and terminal sides but different measures. The measures are going to be different by a multiple of 2 pi or 360, because we're talking, you could rotate around forever till the cows come home and keep going and keep going. And then I'm at 360 and 720, and what comes after that? I don't know, but you could rotate around a lot of times, right? So there's an infinite amount of angles when you're doing rotations that end up in the same spot. So what we're going to do is first learn how to draw coterminal angles. So let's start with negative 210. So we're going to start by imagining that the initial side of my angle is made with the x-axis. Just point for me, which way should I go to rotate negative 210? I should go this way. And then let's figure roughly what that is, okay? So I'm rotating around. I like to do it with the dotted. Now I'm going to stop a second. How far have I rotated now?
90.
Negative 90. And now I'm at negative 180. And how much further do I have to go to get to negative 210? Another 30. So if you would imagine then going another 30 up, that's where my angle ends. I know it's not perfect. Hey, this is where circular comes in. Do you see how I'm doing this in a circular pattern? Okay. I just rotated negative 210. Can somebody tell me its coterminal angle? Coterminal means, how would I get there going the other direction? So what if I went this way instead? How could I figure that out? Yeah, can't you just do 360 minus 210? Yeah. And it is 150 degrees. Okay, hold on. What if I wanted to go, remember I said there's an infinite number of answers? Okay. What if I went 210 and I wanted to keep going that same direction and get back to the same spot? How much further would I have to go? Another negative 360. So another angle would be as if I did this. What's negative 210 plus negative 360? Negative 570. I'm just following the instructions. It says find and draw one positive and one negative angle that is coterminal with the given angle. This is one positive one, that's one negative one. If you wanted more positives, you could add on 360s. If you wanted more negatives, you could add on more negative 360s. Okay? Okay, oh man, 13, ooh, sorry, let's go back. I did not put this in the example, but let's review this. What angle is made with the x-axis? What angle is that? 30. Remember how we went 30 past the 180? Yeah, that's called a reference angle because we're going to use it to make a reference triangle in a second. 13 pi fourths. All right, let's figure this out. Let's not convert it. Let's use some fractions. 4 goes into 13 how many times? Okay. 3 pi, and would you agree that that's also 1 left over?
Yeah.
Okay. In your heads, let's remember pi is the same as 180. So we're gonna rotate 3 180s, and then we're gonna rotate another pi fourths. Do you see this is positive?
Yeah.
So we're gonna go up. All right, here we go. Man, Easton, you're so tired. Okay. How far did I just go? Do it in radians. Pi. I'm still going. Now I'm at 2 pi. Now I'm at 3 pi. Agreed?
Yeah.
Okay, now I have to, I rotated my 3 pi, and hopefully you're noticing because I went more than 2 pi, I'm back into the same spot as I was after 1 pi. Now I need to go another pi fourths, and pi fourths is just 45 degrees. Remember we learned that? So now go another 45 degrees and stop right here. Okay. Oh, this is going to be really easy. So we need to do, we need a positive and a negative angle. So I'm going to do the positive first. See, I just highlighted in pink. How far is that? Pi plus pi fourths. Okay, so one of my angles, I'll call it theta, is pi plus pi fourths. Another way of writing that, if you want to, is pi, or 1 pi is the same as 4 pi fourths plus 1 pi fourths. So another way of writing this is 5 pi fourths. This is how we're going to start writing it later on, okay? So now let's go the other way. This is a slightly different. How far have I gone so far? Pi half in the negative direction, and then a negative. Yeah, so I now, for my negative answer, is negative pi halves plus negative pi fourths. Let's do a common denominator. I'm going to multiply this by 2. Negative 2 pi fourths plus negative 1 pi fourths is the same as negative 3 pi fourths. That's how you do it in radians. Okay. What else do we got here? Do you need me to stop and let you think? Okay, now let's bring 4-1 and 4-2 together. I'm going to show you a way with circular functions. I tend to be a person who doesn't like to memorize formulas. I like to just remember concepts. And since all of you already know that sine is so, ka, toa, I'm going to show you this with X's and Y's and R's, but if you want, you can just do it the same way we did it in our opener today. Just understand, we're going to have triangles now, though, that are in this quadrant, and in this quadrant, the X value is negative, isn't it? Okay, if I went to this quadrant, the Y value is negative and the X value is negative. What that means is this is why we call it a reference triangle. It's not a real triangle. Because in geometry, did you ever have a triangle that had a negative length of side? No. So you are going to have that because we're dealing with different quadrants here that have different signs. Okay. If we had Pythagorean theorem, I hope you would agree with me that the radius would be x squared plus y squared. Okay, here's what I'm saying. Yeah. Draw a little triangle. Drop that down. This ordered pair right here. Wouldn't you agree its x coordinate would tell you how far it went from 0? And it would be negative, right? Okay. Wouldn't you also agree that its y coordinate would tell you that piece? If you made a triangle and you made this theta, the reference angle, y is which piece? The opposite or the adjacent? Opposite. And x is the adjacent. So I'm going to refer to it as x and y, but if you don't want to do that and you just want to draw these and just still do SOHCAHTOA, I am cool with that. It just kind of lays the groundwork for unit circle. Why am I calling this r? Because it's the radius of a circle. It's also the what in a triangle? Hypotenuse. So hopefully you understand where this formula comes from. It's just the Pythagorean theorem. Okay, so if you it's kind of a shortcut now. If you don't want to draw a triangle and you just want to use the ordered pairs, here's how you can do sine, cosine, tangent, all that business. Sine is opposite over hypotenuse, correct? So you could just take the y value and divide by r in this triangle. Cosine would be what? Ka. X over r. Tangent would be y over x. Cosecant, let's just flip these around. R over y, r over x, and x over y. Just understand that today, when I do a reference triangle, you're going to have, like I said, negative sides because you might be in a different quadrant, okay? Over here, which coordinate is negative? The x. So anything that had an x in it is going to have a negative value. This would have a negative cosine, a negative tangent, a negative secant, and a negative cotangent. The r is always positive because, you know, if you do a squared plus b squared equals c squared, isn't that always going to be, okay. If you were down here, let's say I was down here, wouldn't the x and y both be negative? So that would impact things with both an x and a y. Where would it always be positive? What quadrant? What's the only quadrant that would have both x's and y's that are positive? Quadrant 1. Okay. All right. Now, you ready, Easton? Yep.
Yeah.
Okay. What is this? I'm not doing the unit circle yet, but here's the beauty of the unit circle. You're never going to get this until you're older, maybe, and then maybe you won't. What if I made all of these radiuses up here 1? Then what would the sign be? If I made the radius of this circle 1, what would the sign be?
4.
Say it louder. Just y. What would the cosine be? X. And the tangent would just be, well, still, y over x. The reason why we make the unit circle is to make this easier, not harder. Okay, let's do one. Then we're going to do some whiteboard. Okay. So what we're going to do is kind of like we did in our opener today, but now I'm writing it as ordered pairs. I'm going to do this one, okay? Would you draw an XY axis, please? Okay, would you plot the point 3, -4 and label it, please? Would you pretend that you start an angle over here and you rotate it all around and you end your angle here? And would you draw then the terminal side, which is right there? So this is the initial side. This is the terminal side. Technically, theta is this angle. Okay? It's a big angle, isn't it? For our purposes, we're going to use a reference angle. So where is that angle? We're going to use the angle made with the x-axis for our triangle. Now we're going to draw our reference triangle. Would you take your point and bring it up to the x-axis? Do you see the reference triangle here? Okay. Now you have to make a choice. You can either use these up here, or you can just do SOHCAHTOA. If you're doing SOHCAHTOA, make sure you treat this as a +3, this is a -4, okay? What's the hypotenuse? Ooh, who remembers I memorized these ones? 5. 3 squared is 9, plus 16 is 25, this is 5. Okay. What's the sine of theta? Use the ratio up here, y over r, or use opposite over hypotenuse. What's the y coordinate? -4, correct? And what's r? 5. Sine is -4 over 5. Cosine is the x coordinate, or the adjacent, over hypotenuse. What's that? 3 over 5. Tangent. Careful, sine, yep. -4 over 3. Now let's do reciprocals, and we'll just flip them around. I'll put them over here. The reciprocal of sine is cosecant of theta. It would be 5 over -4. Secant of theta is 5 over 3. Cotangent of theta is 3 over -4. And by the way, does the negative have to be with the 4? No, you can put it out in front if you want.